This is obviously one way where you try to solve a problem that is not solvable with classical automation. The nice thing is that you usually have a pretty defined business case already. The downside is that it's usually a pretty complex problem, otherwise they would have solved it already. Then the other way around, if you go top down,
Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to the latest episode of the Trend Detection Podcast. I'm really pleased to be joined by a brand new guest, because I often have a lot of recurring guests on this podcast, but a brand new guest, and one of my Siemens colleagues, Christian Zillner, is joining us today. And we're talking about the very important topic of industrial AI. But we're actually, I know it's one of these phrases which is often used, but we're going to sort of ground it in some reality, particularly on how to deploy it and get real value from it ultimately is what we're looking at. But before we sort of dive into that, I'll hand over to Christian just to introduce yourself, and welcome to the podcast.
Hi everyone. My name is Chris. Thanks for having me. As already mentioned, I work for Siemens. I'm heading the global AI deployment team in DI automation. Means that I am in touch with a lot of projects and use cases where we deploy AI on the shop floor at our customer premises together with partners in this fast-moving environment. It's a lot of fun, a lot of learnings, and I'm very happy to be here.
I guess just a question, sort of a little bit off topic for what we sort of planned, but you mentioned all the different use cases. Is that a good thing to have lots of different use cases to focus on, or is it, can it be quite challenging from that perspective? Because usually people say focus on things, right?
Yeah, focus definitely is always a good idea. I think from my perspective, we're just working in so many different verticals with different requirements. Some are very close to our shop floor where we're having what we call adaptive control. This means like AI really controls processes on the shop floor. There are very different requirements to, some monitoring or predictive maintenance of pumps in a, pipeline of gas or whatever you want to monitor. So this is the variety we have to handle on the Siemens side, but it's also very interesting to always see the same learnings all over. Focus is always a good idea.
Yeah, no, exactly. Maybe I already knew the answer to that question, I guess, but I thought it was interesting to ask anyway. But and I guess today we're actually looking at that journey from an AI lab all the way through to the shop floor, and I guess the value sort of generated there. And we're also focusing, I mentioned in the intro, around deployment as well. So what does that actually mean to you, Christian, in practice?
Yeah, it's a very big word, obviously. But for us, what we realized and learned over time is that deployment really is working with our customers, because usually an implementation of AI or scaling of AI on the shop floor where you need to bridge IT and OT interests is kind of a change process. We usually trigger a lot of responsibility processes, scoping of business cases, financial decisions attached to it. And then obviously there's also the technical implementation, but it's just a part of this whole deployment cycle we're in. And obviously we always try to do that in line with partners and internal teams and then customer teams. So it's quite a bit of a tricky, complex environment we're in there, but it's also very interesting, obviously.
I noticed you've mentioned sort of partners a couple of times already. So what's a partner's role in these projects? Both their importance and, what do they bring to the table?
What we learned over time is that it is crucial if you want to really scale, and I think you called it from the lab to the shop floor. If you really want to implement real industrial AI use cases, you need to have an owner of the application. What we mean by owner is that someone who services over the lifetime of the application. It's no different to any automation project you're probably used to. And those system integrators, machine builders, global solution integrators are our partners on their journey to implement. And this is the one kind of partner. And then obviously we also have technology partners. We partner with camera vendors. We partner with other software players. We even partner with cloud providers where we try to standardize the deployment architecture. So there's ecosystem is really, really important to make it a successful implementation.
You mentioned successful implementations, but quite often, and you'll be able to tell me and the listeners better than anyone, that a lot of industrial AI pilots, show a lot of promise, but don't scale at the end of it, unfortunately. I mean, so for what you've seen, what are the key reasons behind that? And maybe also on the flip side, where do you see the success factors? What success factors are involved?
Oh yeah, we can confirm, as Siemens has a lot of own factories ourselves, I was responsible for implementing AI in our own factories as well, and we failed many times. My very subjective learnings there are that expectation management is key in combination with the business case, because usually those use cases develop over time. So you need to have a good backing and quite a bit of a business case to finance an industrial AI use case. And a second, we bet in the past a lot on custom architectures, and we heavily regretted it afterwards in the scaling phase, because if you're locked into custom solutions, it's really hard to enable operation services that are mentioned before for partners taking over the solution, doing MLOps services, providing it is really, really hard if you don't have any standards.
And so what I'm hearing there is when these projects don't get off the ground, is it usually a technology problem or something else? You've sort of mentioned, I think, with the architecture you mentioned there, but are there other factors at play as well?
Yeah, obviously the evolution of model availability in our space is just enormous. So we have a lot more possibilities, and the accessibility towards machine learning platforms to train models is evolved a lot in the last couple of years. So most of the predictive quality inspection, vision use cases, also robotic, physical AI use cases we see and we implement, the model side is pretty much covered. The second bigger hurdle is obviously then data availability. And this connected to a standardized approach of how to collect data, how to provide it for model training, and then obviously connect the models on the shop floor with the real sensors is a challenge because there's no standards for IoT platforms yet that standardize this whole process from cloud to edge across all verticals and all use cases we see there. So this is definitely quite a bit of challenge. And then the third thing is the deployment platform, where we see great progress with GPUs availability. But this is connected then a lot with the price point and the business case I mentioned before already, because you can spend quite a bit on compute if you want, either in the cloud or on the edge.
I mean, maybe we're leaning more into sort of the adoption of technology here, but are there cultural factors that complement what you were explaining there on the technology side?
I think you have to have a look on who drives the business case or who drives the use case. Obviously, the profile and the capabilities of a OT team or shop floor team is very different to maybe a data science IT-minded team. And for an industrial AI project or a deployment or even a scaling, you need different profiles. And we always differentiate them on first the domain expert that really knows the process well. He's usually responsible for the business case, seeing the implications, safety, quality, all of this. Then we have the IT personas in it. It's a lot about security, CRA, compliance, Cyber Resilience Act compliance is a big issue these days. Then we have the data science team doing the data engineering, selecting the model, do model validation, and then you need some kind of connectivity guy that bridges the gap from like data collection on the shop floor, bringing it to the cloud or to the compute environment where you train the model, and then reverse it back and bounce the model back to the shop floor then. And the fifth, obviously, is once you've delivered the project, is then service, where you need guys to take care of the MLOps services. So it's quite a bit of a cultural aspect in it because you have different personas. And we try to reduce the complexity by a lot with UX or UI. So Gen AI also helps us a lot to reduce complexity in the interaction of engineering. But we're still not there in the whole lifecycle or MLOps lifecycle.
Yeah, maybe let's dive into that a little bit. You said generative AI is helping to make the complex less complex. Like in what ways? What examples can you provide?
usually an OT engineer doesn't have any Python programming skills. So if we have a Copilot kind of interface where he can do intent-based engineering for, I don't know, some kind of just making up an example, a vision solution where he wants to detect scratches on a metal sheet or whatever, then intent-based engineering could be a key to enable an automation guy to set up and sketch and develop an industrial AI solution and train a model without any data science know-how. So this enables us to scale. And the cool thing is, if we could do that, we could reintegrate in the already existing service processes because automation knowledge is there. So talking again about machine learning operations, if some guy or if an industrial AI solution only requires automation knowledge, we are a lot further down the road in AI adoption.
And I know we're sort of jumping back to what you were saying before, those different personas. It's interesting because with so many different personas involved in a deployment, is there someone who actually fully owns the deployment from your perspective, or is it a shared ownership model? How would you sort of describe it?
It obviously always depends a lot on the use case, but yes, we always say that IT owns the standards and the security, and OT owns the use case, because the incentivization is quite different. IT is incentivized on security, and OT is incentivized on efficiency, output, uptime, all of those. So this is how we usually split it. And then if we translate what you just asked, is that the use case usually stays with the OT, which means that the solution has to be serviced by the OT department or business unit.
And is that ownership always clear from the start within an organisation? I know it depends, of course, between organisations and what use case, but is it always clear straight away these are the defined roles, or can it get a bit blurred sometimes?
It's very blurry. Usually we have we have those C-level things where two C-level guys say, we want to do something with AI on the shop floor. Or we have those bottom-up use cases where a guy tried everything from classical automation to smart sensors, smart cameras, whatever, and then ends up at AI vision, for example, because he could not find another way to solve his problem, but it's a significant problem, so he wants to throw some money at it, or it's significant business-wise for him. So those are two very different directions, and either of them has different responsibilities, budget, constraints, and all of it. But as part of our deployments, we usually develop racing matrix with our customers to see the responsibilities, accountabilities within the shop floor deployment, and then obviously services is one of them.
But I guess to sort of shift gears a little bit, another thing I wanted to cover today is sort of the difference if we're looking at industrial AI in terms of the deployment of these projects, cloud versus edge, and where you see things at the minute is, is it leaning towards one or the other, or, are organizations thinking, in a certain way around this topic? Maybe you could go into that a little bit.
Yeah, I think AI adoption is heavily structured in three maturity processes. One is model availability. There we did already quite a huge progress in the last couple of years. Then we have data availability. This is heavily connected to Azure Cloud. And then we have the deployment or the inference. Maybe you heard of that buzzword a lot, like where to deploy my AI on. And data and inference is a different thing. So I think you need quite a bit of a hybrid approach to collect data and then push it to the engineering environment where you have the possibility to train your models, validate all of it. This is one thing. And then you need to choose a deployment environment. So where you want to do the inferencing of your AI model. And this is very dependent on your use case. If you have very high latency and very high security requirements, you usually go edge only. If you have less latency requirements, like if you do monitoring of a pipeline, just coming back to my example, where you maybe do one or you have to do one prediction a minute, then you can easily also go cloud. A second factor is the data format. If you want to push all your data to the cloud providers will love it because it will be enormously expensive if you talk about vision data. We have use cases where you have 16 cameras to connect it to one AI model. So it will be large amount of data streams that has to be orchestrated. And there, usually we go to edge and then just have like data collectors that collect or sort the data that you want to push to the cloud and later on.
So that's the way around, sort of the rising costs of cloud, or that could potentially be from that particular use case you mentioned.
Yeah.
Taking a step back a bit, because I know we've talked about use cases, and clearly that's an important part. Because before you deploy AI, you need to know sort of what use case or problem you're looking to solve. So, what does that look like in your world? Sort of, what's the process for defining use cases with a customer?
I think it's two ways. The one way is if you have like a shop floor problem that you want to solve because it's immensely important for the factory output, or and you go in basically bottom up. This is obviously one way where you try to solve a problem that is not solvable with classical automation. The nice thing is that you usually have a pretty defined business case already. The downside is that it's usually a pretty complex problem. Otherwise, they would have solved it already.
Sure.
Then the other way around, if you go top down, like headquarter down, it's obviously the scaling is a lot different. If we, for example, take a vertical like consumer packaged goods, you have a lot of standardization. We usually look at very standardized processes and try to get into those standard architectures or line setups. The AI or the industrial AI solution or use case already implemented and standardized, because then you have a copy and paste approach while scaling. Keep in mind here to choose the architecture upfront, because then if you want to scale and it's custom and not serviceable, it's obviously the cost of failure is a lot higher.
Yeah, I guess you touched upon it then there a little bit, Christian, but maybe we could dive into that a bit more. So we've talked about the problems of getting these projects sort of off the ground, maybe in a pilot phase, but equally at scale, clearly success has been achieved on one level, but what sort of issues become clear? And you mentioned architecture could be one, but what other sort of challenges sort of appear as these projects scale upwards?
I think the first thing is always use case definition connected with the business case, but this is no different to any other automation project. So don't be too scared here. I think it's the same, just do your job in scoping the project, defining success metrics, scope of work, all of that. I think this is equally important for an AI project, or even more important. Second, obviously, is data availability. There's shit in, shit out. If you have unreliable data that is not standardized, it will be costly or even not reliable in the end. Third is model development. Obviously, you need a good data science partner, or you do it yourself. It's your choice as a solution owner if you want to own it and see the model development as your core competency, or you want to have it in-house, or you partner here. And then fourth is the deployment environment, as mentioned before. Here, I think it's important. The one side is the data connectivity to standardize and productize this. And I would strongly recommend you to partner there because connectivity is a key issue for shop floor data. And as it is critical, it's very important. And then the other bit is the inference environment you want to choose, whether it's in the cloud or on the shop floor with edge devices locally hosted, or then in the cloud.
And it's interesting that you were sort of balancing, whether to own stuff for the organisation to own it or outsource that potentially, and particularly on the model side. I mean, do you have a recommendation either way, or is it very much down to the use case, the organisation, how they want to approach things? There's no right or wrong. It's just what's the right approach for them, maybe.
I think the right approach is what you can service. If you have global availability of data science services within your corporation, you can do it in-house. If not, partner.
Yeah, that keeps it very simple, right? When, I guess the danger is with some of this, or a lot of this, is to overthink it, but that keeps it very simple. So that's good. That's very good. And I guess going back to the scale question as well, because you've mentioned the importance of consistency, particularly with architecture, and I'm sure there's other areas too. But I guess there's also got to be elements of flexibility as well. So I'm just interested how you sort of balance those two very contrasting things in a project when scaling in particular.
I think this is strongly connected. In our case, we have the approach of partnering. This has always been our business also in automation, where we have system integrators, line builders as partners. And it's the same for AI solutions. We try to have a Pareto of like 80% product and 20% solution. And this makes it also an attractive business for our partners. And we are developing what we call verticalized use case offerings there together with our partners, where we try to productize as much as possible. Not saying that Siemens delivers all of it, like not all the hardware. For example, if we go into AI vision, we don't have or we don't have any camera hardware, for example. We partner there as well. But we try to productize as much as we can, between 70 and 90%. And then we have always an adaptability service or like a customized approach to make it a great fit to the customer requirements.
Yeah, that makes sense. That seems like a very good sort of balance between the two. I could relate it back to sort of Senseye, which we haven't talked about predictive maintenance. It's not necessarily we need to, but it just reminds me of Senseye's great value of being able to integrate with existing technology on the shop floor and working with partners and being open like that, which again is Siemens Accelerator. You could even go down that route as well. It's all very much linked together. So as we sort of come to the end, we're going to have a quick fire round in a second. But before we do, I just wanted to ask sort of one final question. It's more about just whether you could provide one sort of piece of advice for an organisation that's looking to move from AI experimentation, because I'm sure it could be tempting to stay in that phase, indefinitely, to find the perfect solution, to go from there all the way through to the large scale deployments we've been talking about. So what's that one piece of advice just to sort of try and narrow it down?
Standardize your deployment platform right from the start. Cost of switching is super high, and I would choose like max 3 scalable use cases that are quite standardized in your shop floor environment, and where you can sync upon with the machine learning operations partner that could help you service it. It can be an internal partner or an external partner. Internal partner, for example, could be your IT team that could take over, or it's an external partner that you work with. Fantastic.
Very clear. So the quick fire round, the name says it all. It's a very quick answers to quick questions. Don't think about it too much. So we've got previews. Let's start. So the biggest myth about deploying industrial AI?
I think there's no one solution covers it all approach possible.
Perfect. And one thing every successful AI deployment has in common?
A good business case.
And if you could choose between cloud, edge, or a hybrid approach, if you had to pick one, which one wins most for industrial AI today?
Hybrid.
Best of both worlds, of course.
Most expensive one, but
maybe. But no, fantastic. We've just introduced that quickfire round, so I'm still sort of testing it out. But it's interesting what responses we get. But no, for today, I think we've come towards the end of our conversation, Christian. It's been fantastic to have you on talking about this very interesting and very broad subject as well. But I guess if people want to find out a bit more about your work, is there anywhere we can point people to?
Yeah, I think easiest is add me on LinkedIn. I think that's one. And you can find us on the Siemens website. So obviously there's a product called Industrial AI Suite, or if you want to check out our AI vision offerings, they're called Inspector. Feel free to check them. And there you can see how we are trying to simplify AI or industrial AI to make it more accessible for automation engineers.
Fantastic. Yeah. So we'll put all those links in the show notes afterwards. In that case, fantastic. But yeah, for today, thank you so much for joining us, Christian, on your first appearance on the Trend Detection podcast. Hopefully not the last, and hopefully we haven't scared you off too much.
Thanks a lot for having me.
No, of course, anytime. Thank you, everyone, for joining us for this episode, wherever you are, wherever you're listening, and we'll see you on the next episode. Thank you.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.